Hey everyone, welcome back to the Data Hustler. In today's video, I am sharing 4 real SQL queries that were asked just 3 days ago in the Amazon Business Analyst Support written test, along with 10 MCQs and 6 logical reasoning questions. These 4 SQL queries made up a total of 100 marks in the exam. If you are preparing for Amazon BA support or any similar analyst role, this video is packed with valuable practice to help you crack the test. So let's jump right in and break down each query with a clear explanation, sample data, and tips you need to succeed. So I have created sample tables for the queries. I have created vehicles tables with these columns, packages table with these 2 columns, and delivery tables with these columns. And I have inserted few values into those 3 tables as well. So our first query is to calculate the delivery success rate for the last 7 days. So pause the video now and give it a try yourself. Alright, here is how I would do it. This query calculates the delivery success rate for the last 7 days. The delivery success rate is defined as a percentage of deliveries that were marked as completed out of the total deliveries for each day. We select the delivery date so we get the results grouped by each date. Then we calculate delivery success rate using this expression. Case 1 delivery status equal to completed, then 1, else 0, end. This condition checks each delivery record. If the delivery status is completed, it returns 1. Otherwise, it returns 0. This effectively converts the delivery status into a numeric indicator for success. Then we are summing this up. Summing up these ones and zeros gives the total count of completed deliveries for that day. Then we are using count star. This counts the total number of deliveries on that day regardless of their status. Dividing the sum of the completed deliveries by the total count gives the success rate as a decimal. Multiplying by 1.0 ensures that the division performs floating point arithmetic, decimal division, not integer division. Without this, you might get 0 or incorrect results if both numbers are integers. Then we are rounding up with the 2 decimal places, so the output is clean and easy to read. Then we are using the from clause. We are querying data from the deliveries table, which holds records of all deliveries including their dates and statuses. Then we are using a where clause to filter or restrict the data to only the last 7 days including today. And we are using CUR date, which returns today's date. Then CUR date minus interval 7 day returns the date 7 days before today. Then between operator includes both endpoints, so the query covers 8 days in total, today plus the previous 7 days. If you want exactly the 7 days including today, you could adjust the interval accordingly. Then we are using group by. We group the data by delivery date to get daily aggregated results, 1 row per date with the success rate for that date. So let's run the query and see the output. So here is the delivery success rate for each delivery date. I hope you were able to understand that one. Moving on to the second one. Second query is to find, for each vehicle type, we have to find the average weight and the successful deliveries. Pause the video now and try to give a shot by yourself. Alright, here is how I would do it. This query helps us analyze delivery performance by vehicle type. Specifically for each vehicle type, it calculates the average weight of packages successfully delivered, the total number of successful deliveries made. This kind of analysis is crucial for logistics and operations teams to understand how different vehicles perform and what kind of loads they carry. Then we are using from and join clauses. We start with the main table deliveries, which contains delivery records including the vehicle used and the packages delivered. We join the vehicles table on vehicle ID so we can group results by vehicle type. We also join packages table on package ID to access the weights of each package delivered. These join allow us to combine delivery result with vehicle info and package info in one result set. Then we are using where clause to filter the deliveries to include only those with the delivery status as completed. This means we are considering only successful deliveries. This ensures that the averages and the counts are meaningful. For example, we don't want to include failed or cancelled deliveries in the statistics. Then we are using select clause, vehicle type. We select the type of vehicle to group the data accordingly. Then we are rounding those averages for getting the 2 decimal places. Then we are counting the successful deliveries, number of completed deliveries for each vehicle type. Since we filtered on completed status, this count only includes successful deliveries. Then we are using group by. We group the entire result set by vehicle type. This means the aggregates. Average weight, the count will be calculated per vehicle type. This query combines data across 3 tables to give insights into delivery operations. It answers the question, for each vehicle type, what is the average package weight carried and how many deliveries were successfully completed. Understanding how to perform multi-table joins, filter data, aggregate and group results is essential for any business analyst or data role, especially in logistic heavy companies like Amazon. I hope that was pretty much clear for you. Moving on to the third query. So for the third problem statement, I have created 3 more tables: customer table with these 2 columns, category tables with these 2 columns, and orders table with these columns. And I have inserted few values into the customers table, categories table, and orders table. And our third query for the day is how much each customer spent on books. So here is the table, and I want you to pause the video for a moment and give a try by yourself before looking into my answer. Alright, here is how I would do it. This query calculates how much money each customer has spent specifically on the books category. This helps business understand customer spending pattern within a particular product category. In the select clause, we select customer ID and customer name to identify each customer in the results. We use sum of the total amount to calculate the total money spent by each customer on books. Then, with the help of from and join clauses, then the main table here is customers aliased as C. We join the orders table on the matching customer ID to connect each customer with their orders. Then we join categories table cat on category ID from the orders to link orders to their product categories. This chaining of joins allow us to associate customers, orders, and categories. Then with the help of where clause, we filter to include only those orders where the categories is books. This means we only sum up the amounts for orders related to books, ignoring all other categories. Then with the help of group by clause, we group the results by customer ID and customer name so that the sum function calculates totals per customer. This ensures that the final output lists each customer once along with their total spend on books. Companies often want to analyze category-specific revenue to tailor marketing promotions or loyalty programs. This query helps identify top book buyers or customers with a low spend, so targeted campaigns can be designed. Also useful for sales forecasting and inventory management. That was an easy one. Moving on to the final query for the day, to find the total quantity sold by category. So pause the video now and try to give a shot by yourself before looking into my answer. Alright, here is how I would do it. Here we select 2 things: category name, the name of each product category like books, electronics, clothing, etc. Second, we calculate the total quantity of items sold for each category using sum of quantity. This sums up the number of items ordered across all the orders for that category. We give this result an alias called total quantity, so it's easy to read in the output. The data we start with is from the categories table, which contains all the categories available in the system. Notice we give it an alias cat to make referencing easier later on. Now we join the orders table to the categories using a left join. This means we want to keep all categories even if they have no corresponding orders. The join condition matches rows where the category IDs are the same in both tables. We alias the orders table as O. Finally, we group the results by each category name so that the total quantity is calculated per category. Without this grouping, SQL wouldn't know how to aggregate the quantity correctly. So why do we use a left join here instead of an inner join? Because some categories might have 0 orders. For example, a new category just launched. A left join makes sure that these categories still appear in our results with a total quantity of null, which SQL treats as 0 in aggregation. So in the output, a list of all categories, each with the total number of items sold, will be present. Categories with no sales will still appear but show as null or 0 in total quantity. This query is super useful for reporting. You get a complete view of all categories including those with no sales, helping identify slow movers or inventory gaps. That's a wrap for today's video. I hope you found these 4 SQL queries from the Amazon BA support written test useful for your preparation. Remember, practicing real questions like these is the best way to boost your confidence and get ahead in the selection process. If you want more videos with a detailed explanation, hit the like button, subscribe to the Data Hustler, and ring the notification bell so you never miss an update. Drop your questions or doubts in the comments. I'll be happy to help. Thanks for watching and keep hustling towards your data career dreams. See you in the next video. Bye bye.